Hello everybody, this is Dr. Nur Shah from University of Engineering and Technology, Peshawar. In this video, I'll be talking about shifted inverse power method, which is mainly used for finding a relative eigenvalue of a square matrix A. In this video, my main focus will be how do we use calculator to find a relative eigenvalue of a matrix A. So let me give a brief description of the method. Let's suppose we have a matrix A and we want to find an eigenvalue close to a number gamma, and obviously it's a numerical method. So how does it work? Let's suppose we have a matrix A, right, and its eigenvalue close to gamma. Let's assume that it is lambda. So if lambda is the eigenvalue of matrix A, then by definition of eigenvalue and eigenvectors, there will be a non-zero vector x such that Ax is equal to lambda x, right? And then what do we do? You see that lambda is very close to gamma, so that means lambda minus gamma, that will be very small. That will be small, okay. So in that, to reach to this point, what do? We subtract gamma x from both sides of this equation. So we get lambda x minus gamma x as well. And then we can write this in the form A minus gamma I, where I is the identity matrix of same order as of A, x, that will be lambda minus gamma x. Keeping in mind, using distributive law, we are taking x common from it, and as you see, A is a matrix, so there will be identity matrix with gamma, whereas on the right side, lambda and gamma both are constant, they are scalar. So if we take this common from it, that will simply give you lambda minus gamma, and in this case, we don't need to multiply these constant with identity matrix. From this equation, because this is a vector, right? So from this equation, we can say that lambda minus gamma is the smallest eigenvalue value of the matrix, the new matrix, that is a shifted matrix, that is A minus gamma I. Keeping in mind, what do we mean by A minus gamma I? A minus gamma I basically means that in the square matrix A, you would only alter the diagonal entries by subtracting gamma from it. That's the first diagonal entry is A1 1 minus gamma, A2 2 minus gamma, and A3 3 minus gamma. You don't need to change the other values. The other values will remain the same if we have a 3 cross 3 matrix. So that's simply the shifting of diagonal entries. So if we say lambda minus gamma is the smallest eigenvalue of A minus gamma I, this implies 1 over lambda minus gamma is the largest or dominant eigenvalue of A minus gamma I inverse, which means we would apply power method in this case on the matrix A minus gamma I whole inverse. So the steps are, you will be given a matrix A. Step number 1, you find a matrix B or whatever, you just find this matrix A minus gamma I, which will be obtained by subtracting gamma from the diagonal entries of matrix A, right? And then let's call that matrix B, whatever you call it, doesn't matter. and then you find inverse of this matrix B, and applying then power method on B inverse, for which we choose a vector x, initially vector may call that 0, and that will be a non-zero vector. We find y that is obtained by multiplying B inverse with x0. Then we look for the numerical largest value in y, and we call that mu1, right? That's the numerically largest value of y, which is usually we take that it's the component of a vector y, which is the infinity norm of the vector, this one. Y1 absolute will be basically what? That will be the infinity norm of y. And then we normalize this vector y and call that as x1. So x1 will be like y divided by mu1. And then we repeat the process. The next time we find y again, and y will be now again multiplying B inverse with that new vector x1, and then again find mu2. Mu2 will be the component of y, which is defining what? Which is the absolute of infinity norm, and so on. That's the procedure where we find all the values. So once we are done with it, at the end, what would we do? At the end, we basically found an eigenvalue, which is the largest eigenvalue, 1 over lambda minus gamma. That will be the mu k if we have stopped this process after k iterations. So in this case, you would solve this forward for lambda. So lambda would simply give you lambda is 1 over mu k plus gamma. That will be the relative eigenvalue of a matrix A. And x will be the corresponding, that is xk will be the corresponding eigenvector. Let me explain this by using example. That is, we want to find eigenvalue of this matrix A near to gamma is -2. So step number 1, we would find this matrix B, which will be, as I said earlier, that will be A minus gamma I. That means A plus 2i, because gamma is -2. That means you would find 10, 2, 7, 1, 1, 1. That's -1, 1, -3. And then plus we have 2, 0, 0, 0, 2, 0, and 0, 0, 2. So what would we have? We simply have that's 12, 12, 2, 7. Then we have 0, 3, 1, 3. And then we have 1. And then we will be having -1, 1. And the last value will give you -1. Right? So this is a matrix whose inverse need to be found. And then we apply a power method. So I'll do that these steps by using calculator. So let's move to the calculator. Okay, let me keep all this. Okay, so if you go to the next step, in that step iterative values are given. So what would you do? How do we do that? By using calculator. I just open the calculator. The step number 1 is what you would simply convert the mode to matrix mode. So mode of the calculator should be matrix. That means you have to press 6, and then we need to have a matrix A first. So matrix A, that is pressed with 1. The order of the matrix should be 3 cross 3, so I just pressed 1. So I'll give you the values like this one. The matrix is this, as I said earlier. What would you do? Simply subtract the number gamma from there, so it's -2. So this value will be 12. Then press equal. The next value is 2. the next value is 7, then we have 1, press equal, then we have 1 again, sorry, it's not 1, it's 3, and then we have 1, the last entry, then we have -1, +1, and -1. So that's our matrix, which is already done. So in the next step, we would need the initial vector that is labeled as x1 or x0. So how do we do that? So just delete that one or just close this one and start with a matrix again, and then we go for data. We will be looking for another matrix that is 2, and the order should be 3 cross 1, so it is 3, and we may take the values as the previous the initial guess is given, that is taken to be 311, so we'll just take 311. So I'll take 3, then 1, and then 1 as well. So that is done now. We have the matrix A, we have the matrix B. Keeping in mind the matrix A inserted here is basically that matrix A minus gamma I. So if I want to find the first iteration, so what would I do? I just shift again, press shift 4 with shift, and then I'll just call the matrix A first, and inverse of this matrix multiplied by matrix B, which is 4 here, and then I press equal. So you see that I am getting 1.1, then I am having 0.5, the next value is minus 1.6. So the largest value in this case is minus 1.6, so I'll just divide this vector. So my mu1 is what? That is minus 1.6, you see this one. So I just divide this value by what? This matrix by what? Minus 1.6. Okay, so that will give me the next, this one, you see the next vector, that's my x1 now. So it is minus 0.6875, the next value is 0.3125, and then we have 1, the last one. Right, so next time what do? We multiply this vector by inverse of the matrix already stored in the calculator from the left side. So how do we do that? I just press multiply, but I'll go to the left because we would multiply that matrix B inverse or A inverse from the left. So that is 3, and then take inverse of it again, keeping in mind you don't need to take the power -1, it's just an inverse because we cannot find power -1 of a matrix, so you have to go for inverse. So that's mat A inverse into mat ans, that is giving you the next vector, which is this one, 0.9531, 0.1719, and minus 1.781. So again, this is the largest value. Okay, so it is this one, minus 1.7812. So I'll just divide this vector by minus 1.7812 to get the next vector, which is this one, right? 0.5351 and so on. And then multiplying this one with what? With the matrix again from the left. So I just go to the left and then shift, press 4 multiplied by matrix A, that is 3, taking the inverse, and then press equal, you will get the next vector, this one, right? You see this one. So it is minus 1.6605 is the largest one. Next time divide the same this vector by minus 1.6605 to get so on, and then we will be converging to the value minus 1.6834 and so on. So you see that the value is converging towards this number minus 1.6837, the next one is minus 1.6834. So this eigenvalue is correct up to 3 dp And if you want to stop here, so this is basically what that is 1 over lambda minus gamma. This quantity is equal to minus 1.6834. You will take reciprocal of this value, and that, and then subtracting, adding minus 2 to it to get minus 2.5940. And this is the corresponding eigenvector as well. So thank you very much. I hope you have got some idea how to use calculator to find a relative eigenvalue. Thank you. Subscribe to my channel. See you in next video.